Hello everyone and welcome back to the channel. If you have followed our last video, you saw the magic of Docker. We packaged our application into a single portable container. It solved the but it works on my machine problem. But that was just one container. What happens when you need to run dozens and hundreds of them? How do you keep them running, scale them up, and during traffic spikes and update them without any downtime? You can't do that manually. Today, we are going to answer that question by introducing this industry standard for managing the containers at scale, that is Kubernetes. Imagine you have a popular web app. You don't just run one container, you run several copies of for reliability. What if one of those containers crashes? How do you automatically start a new one? What if a big sale drives a lot of traffic? You need to scale from 3 containers to 20 and then back down again. And what about updates? You can't just take your site offline. You need a way to roll out new versions of your app's application gradually. And if something goes wrong, roll back to the old version instantly. This is where container orchestration comes in. You can think of Kubernetes, often abbreviated as K8s, as the conductor of your container orchestra. It's an open source platform that automates all the hard work we just talked about. You simply tell Kubernetes what you want. For example, I need 5 copies of my Node.js application to be running at all times, and Kubernetes takes care of the rest. It places them on the right servers, restarts them if they fail, and ensures they can all talk to each other. It's the ultimate set it and forget it tool for your containers. To work with Kubernetes, you just need to know a few core concepts. Starting with a pod. A pod is the smallest basic unit of deployment. Think of it as a logical host for one or more containers. While a pod can contain a single container, it can also hold up a group of tightly coupled containers that needs to share resources. Most importantly, pods are designed to be temporary and disposable. This is a key to how Kubernetes manages them automatically. Now you sorry. Now you don't manually create pods. Instead, you create a deployment. A deployment is a higher level object that manages a group of identical pods. It's how you tell Kubernetes your application's desired state. The deployment's job is to make sure your actual state matches your desired state. If you say you need 3 replicas of your application running and one pod fails, the deployment will automatically spin up a new one. This is also how we will handle scaling our app and rolling out new versions. Pods are temporary, so their IP addresses can change. Your users need a stable address to access your application. This is where a service comes in. A service provides a fixed IP address and a DNS name. You can think of a service as a load balancer that sits in front of your pods. It automatically routes incoming traffic to the healthy pods in your deployment. This ensures that your application is always available and your users have a single stable point of entry. Alright, enough with the theory now. The best way to understand Kubernetes is to use it. For our live demo, we are going to take the Docker image we built in our last video and deploy it using Kubernetes. I will show you how to write 2 simple YAML files, one for our deployment and one for our service. Then we will use the kubectl command line tool to deploy our application. By the end of this video, you will see your first fully managed scalable containerized application running. Alright, enough with the slides. Let's get into our hands dirty and see how Kubernetes works in action. I'm going to switch over to my terminal now and show you how to deploy the exact same Node.js application we built in the last video, but this time we will use Kubernetes to manage it. Before we start, you will need 2 things. First, the Docker image we built in the last video, and second, a local Kubernetes cluster. I will be using a Docker desktop which comes with Kubernetes built in, but you can also use a tool like Minikube. The first thing we need to do is tell Kubernetes what to deploy. We do this via YAML files, which are the standard way to define Kubernetes objects. We need 2 files, one for our deployment and one for our service. I have already created and saved these files in my demo directory. This is a common practice to keep our workflow smooth. Let's look at the content of the deployment YAML file first. As you can see, this file is a declarative blueprint. It tells Kubernetes, I want to I want a deployment named my node app deployment with 3 replicas. Each replica should run a container from the node my node app latest image and expose it to 3000. Expose the port 3000. Notice the image pull policy. It is never line. We have added this to tell Kubernetes not to try to pull this image from a public registry, as it's already available on a local Docker daemon. Now let's look at the service.yaml file. This is what will expose our application to the outside world. This file creates a service named my node app service. The selector is crucial here. It matches the label app my node app from the R deployment. So the service knows exactly which ports to send traffic to. The service will listen on port 80 and forward request to port 3000 inside our containers. We have used the load balancer type, which is the standard way to expose a service in a production environment. Now for the fun part, we will use the kubectl command line tool, which is how we interact with Kubernetes cluster. The command to create our resources from these files is kubectl apply -f. So I will type kubectl apply and -f, and for deployment I will specify the file name and then press enter. This command sends our deployment file to the Kubernetes API server. It's now creating our pods in the background. Let me show you. Perfect. As you can see, 11 seconds ago, the pods are running. Now let's apply our service file. I will type kubectl apply -f and then service.yaml and then press enter. This command creates our service, which will automatically find and load balance the traffic to our running pods. We can check our resources. Let's get started and look at pod to see if they are running. I will type kubectl get pods that I did earlier. And you can see that Kubernetes is creating our 3 pods. It have already created and it's running and perfectly. This shows that the Kubernetes is ensuring our desired state of 3 replicas is met. Now let's check our deployment and service. I will type kubectl get deployments. And you can see our deployment is ready with 3/3 replicas. And if I type kubectl get services, here is our service, now my node app service. Note that the external IP is showing as pending. This is an important point. Since we are running Kubernetes locally, there's no cloud provider to give our load balancer an external IP address. So it will remain in a pending state. In a real world scenario on a cloud provider like AWS, this would be public IP address. But we can still access our application for testing using a very useful kubectl command that is called port forward. This command creates a secure tunnel from a port on our local machine directly to our service and bypassing the need for a public IP. I will type kubectl port forward, and this command creates a secure tunnel from a port on a local machine directly to our service, bypassing the need for a public IP. So I will type this kubectl for port forward and then service slash my node app service. Port is 8080 in our local machine and the container port is 80. The service port is 80. Perfect. So this should be enough. So I will press enter. Okay, so Port is now forwarded. I will now open a browser tab and navigate to https localhost 8080. Okay, so I'm in a browser tab now and I will type localhost 8080 and press enter. Great. So there it is. Our application is running and accessible right from our local machine, managed entirely by Kubernetes. You can see the hello from inside a container message we define in our code. Okay. So the real power of Kubernetes is how easily you can scale. Let's say we have a traffic spike and need more capacity. We can scale our deployment with a single command. I will type kubectl scale deployment slash our deployment name, that is my node app, and then deployment. I will specify the replicas equal to 5 and press enter. Okay, so the deployment has been scaled. So what I did is I just told Kubernetes to scale our application to 5 replicas. Now let's check our pods again by typing kubectl get pods. Great. As you can see, Kubernetes is creating 2 new pods. It's already running. It is to meet our new desired state, that is 5. It handles all the underlying complexity for us. And if the traffic goes down, we can scale back at just easily. I will type kubectl scale deployment again, and then replicas would be 1 this time. Let's see the pods after this. As you can see, the pods are being terminated and now only one pod is running. So there you have it. In just a few minutes, we went from a simple single container to a fully managed, scalable, and highly available application using Kubernetes. This is the power of container orchestration, and it's a fundamental skill in the DevOps world. So, in this video, we went from a single container to a fully managed production-ready application. We learned that while Docker is a great tool for building containers, a power orchestrator like Kubernetes is what you need to manage them at scale. But our process is still manual. We have to manually build the image, write the YAML, and run the kubectl command. In a real DevOps environment, this is all automated. In our next video, we will dive into the world of CI/CD, that is continuous integration and continuous delivery, and show you how to automate this entire workflow. Don't forget to like and subscribe to get notified when that video drops. Thank you.